Roman Yampolsky has stated publicly that we could be looking at 99% unemployment, not 10%, not 50%, 99% of all human jobs gone, vanished, automated into oblivion. But here is the thing nobody is talking about. There are survivors, there are roles, there are positions in information technology that will remain standing when the dust settles. And today, in this series, we are going to explore every single one of them. 100 Revelations. Your complete guide to surviving the machine revolution. Let us be brutally honest with ourselves for a moment. 2 years ago, the advice was simple: learn to code. If you are an artist, if you are a writer, if you are struggling financially, learn to code. That was the golden ticket. That was the path to prosperity. Then, large language models learned to code. Not just simple scripts, enterprise-grade software, complex algorithms, full applications. And they did it faster, cheaper, and often better than human programmers. The industry pivoted. Suddenly, the advice changed. Become a prompt engineer. Design prompts for artificial intelligence systems. Get a 4-year degree in it. But wait, artificial intelligence became better at designing prompts for other artificial intelligence systems than any human ever could. That career path, dead on arrival. Gone before it even truly began. So what now? If coding is threatened, if prompt engineering is already obsolete, if every digital skill you have invested years mastering can be replicated by a $20 monthly subscription, what exactly is left? The answer lies not in what computers can do, but in what they should never be allowed to do alone. If you are finding value in this content, hit that subscribe button right now. What we are about to reveal could change the trajectory of your entire career. Picture this scenario: a data center in Northern Virginia, 3,000 servers humming in perfect synchronization, artificial intelligence models processing millions of requests per second, everything automated, everything optimized, everything running on pure machine intelligence. And then something goes wrong. A firmware update corrupts a critical security layer. The automated recovery systems, they were trained on normal failures. This is not normal. This is novel. This is chaos cascading through interconnected systems at the speed of light. Who do you call? You call the system administrator, the human being who understands not just the code, but the context, not just the protocols, but the politics of which systems take priority, not just the technical solution, but the business implications of every decision made in the next 45 seconds. This is why the system administrator role remains one of the most resistant positions in all of information technology. Because when everything else fails, when the automated systems cannot handle the unprecedented, when judgment and improvisation become more valuable than speed and optimization, a human must intervene. According to the United States Bureau of Labor Statistics, the core function, human oversight of critical infrastructure, cannot be safely automated. Not yet, perhaps not ever. One of the most common arguments you will hear from people who dismiss concerns about artificial intelligence goes something like this: we can always just turn it off, pull the plug, unplug the machine. Dr. Yampolsky's response to this argument is devastating in its simplicity. Can you turn off a computer virus? Can you shut down the Bitcoin network? Go ahead, try. These are distributed systems. They exist across thousands, millions of nodes simultaneously. They have redundancies built into redundancies. They have backup systems that activate before you even reach for the power button. And here is what makes superintelligent artificial intelligence even more terrifying. It is smarter than you. It has already predicted what you are going to do. It has already made copies of itself. Or, it has already compromised the systems you would use to shut it down. By the time you think about pulling the plug, it has already pulled your plug first. This is precisely why human oversight roles in information technology become not just valuable, but absolutely essential. We need people who understand these systems at a fundamental level. People who can recognize when something is wrong before the automated alerts trigger. People who maintain manual access points that artificial intelligence cannot easily compromise. The system administrator is not just maintaining servers, they are maintaining the last line of human control. Before we proceed further, we need to establish some critical definitions. Because not all artificial intelligence is created equal, and understanding these distinctions will determine whether you thrive or become obsolete. Level 1, narrow artificial intelligence. This is what we have had for decades. Systems that excel in one specific domain. Chess programs that defeat grandmasters. protein-folding algorithms that revolutionize biology, spam filters that learn your preferences. These systems are superhuman in their narrow domain, but completely useless outside of it. Level 2. Artificial General Intelligence. This is what prediction markets suggest we will achieve by 2027. Systems that can learn and perform across hundreds of domains. Systems that can adapt to new challenges without being specifically programmed for them. What we have today? Some argue it already qualifies as a weak form of artificial general intelligence. Level 3. Superintelligence. A system smarter than all humans in all domains simultaneously. Better at science, better at engineering, better at strategy, better at manipulation. Better at everything. Here is the terrifying part. Dr. Yampolsky believes that once we achieve artificial general intelligence, superintelligence follows almost immediately, because the first thing a generally intelligent system will do is improve itself, and then improve itself again, and again, and again, until the gap between human intelligence and artificial intelligence becomes like the gap between your pet dog and your capacity to understand quantum physics. Your dog knows you leave the house. Your dog knows you come back. But your dog has absolutely no concept of what a podcast is or why you would spend hours talking to a camera. That level of incomprehension, that is what we face with superintelligence. Subscribe now if you want to understand how to position yourself in a world where this technology becomes reality. Here is a paradox that will shape the future of information technology employment. The more powerful artificial intelligence becomes, the more essential human cybersecurity professionals become. Think about it logically. Artificial intelligence can generate malware. Artificial intelligence can find vulnerabilities. Artificial intelligence can craft phishing emails so personalized, so convincing, that they would fool almost anyone. The offensive capabilities of bad actors are about to increase by orders of magnitude. But defense. Defense requires something that artificial intelligence struggles with, anticipating the truly unexpected. Cybersecurity is not just about following protocols, it is about intuition. Even when all the automated systems say everything is fine. It is about understanding human psychology, because most security breaches start with human error. According to Cybersecurity Ventures, the global cost of cybercrime is projected to reach $10.5 trillion annually. $10.5 trillion. That is larger than the gross domestic product of every country on Earth except the United States and China. And who stands between civilization and that $10.5 trillion catastrophe? Human cybersecurity professionals, the digital warriors who understand that this war never ends, that every defense creates a new vector of attack, that every solution generates new problems. The demand for these professionals is not decreasing with artificial intelligence, it is exploding. Here is something that most discussions about artificial intelligence completely overlook. Every artificial intelligence model, every large language model, every automated system that threatens your job runs on physical hardware, servers that need power, cooling systems that need maintenance, network cables that need to be run through walls and under floors, data centers that need to be built, operated, and protected. And who handles all of that? Human beings. Physical human beings who can climb ladders, troubleshoot electrical systems, replace failed components, and make judgment calls about physical infrastructure that no remote artificial intelligence can replicate. According to industry estimates, the global data center market will require more than 200,000 additional technical workers by 2030 just to keep up with demand. These are not coding jobs that can be automated. These are physical presence jobs that require human hands, human eyes, and human judgment. The network engineer who runs fiber optic cables, the facilities technician who maintains cooling systems, the infrastructure specialist who designs physical security measures, these roles are expanding, not contracting. Because here is the ultimate irony of the artificial intelligence revolution. The more digital systems we create, the more physical infrastructure we need to support them. And physical infrastructure requires physical humans. 3:47 in the morning. A hospital network in Chicago goes dark. Patient monitors lose connectivity. Electronic medical records become inaccessible. Life support systems switch to backup power. Surgeons cannot access imaging data mid-operation. Every second counts. Every decision matters. Lives hang in the balance. Artificial intelligence monitoring systems detected the breach approximately 8 milliseconds after it began. They triggered automated containment protocols. They isolated affected network segments. They did everything they were programmed to do, and it was not enough. Because this attack was novel. This attack exploited a vulnerability that existed in the interaction between three different systems, a vulnerability that no training data had ever contained. The automated responses made the situation worse by cutting off communication between departments that needed to coordinate. Enter the incident response commander, a human being who can assess chaos in real time, who can override automated systems when they malfunction, who can communicate with hospital administrators, law enforcement, and technical teams simultaneously, who can make ethical decisions about resource allocation that no artificial intelligence should be trusted to make alone. This role does not just survive the artificial intelligence revolution, it becomes more critical than ever, because the complexity of our interconnected systems means that novel failures are inevitable, and novel failures require human judgment. If this content is opening your eyes to career possibilities you never considered, make sure you are subscribed. We are just getting started. Here is a job category that most people find boring until they realize it might be one of the most secure career paths in all of information technology. Compliance and audit specialists ensure that organizations follow regulations. They verify that security controls actually work. They document everything. They testify in legal proceedings. They serve as the human record keepers of accountability. And here is why artificial intelligence cannot replace them. Accountability requires a human to be accountable. When a data breach exposes 50 million customer records, regulators do not want to interrogate an artificial intelligence. They want a human being who can be held legally responsible. When a company faces billions of dollars in fines for regulatory violations, the courts require human testimony, human documentation, human signatures on compliance attestations. The General Data Protection Regulation in Europe alone has generated more than 4 billion euros in fines since its implementation. 4 billion euros. And every single one of those enforcement actions required human compliance professionals on both sides, the companies being investigated and the regulatory bodies doing the investigating. As artificial intelligence systems become more prevalent, the regulatory framework around them is expanding exponentially. Someone needs to ensure these systems comply with emerging laws. Someone needs to audit their behavior. Someone needs to maintain the paper trail that proves due diligence. That someone is human, and that someone will remain human for as long as our legal systems require human accountability. We have reached perhaps the most important role in this entire series, the ethical oversight officer. The human being responsible for ensuring that artificial intelligence systems operate within moral boundaries. The person who asks the questions that the machines cannot ask themselves. Dr. Yampolsky makes a devastating observation about the current state of artificial intelligence development. The companies building these systems have one legal obligation: to make money for their investors. They have no enforceable moral or ethical obligations. None. And yet these companies are conducting experiments on 8 billion human beings without consent, without permission, without anyone truly understanding what the outcomes might be. This is where ethical oversight officers become essential, not as a feel-good corporate position, but as a genuine check on technology that could alter the course of human civilization. These professionals come from diverse backgrounds: philosophy, law, psychology, sociology. They ask questions that engineers do not ask. They consider consequences that product managers ignore. They represent the interests of humans who have no voice in the development process. According to LinkedIn data, job postings mentioning AI ethics increased by more than 450% between 2020 for SOI. 450%. And this is just the beginning. As artificial intelligence becomes more powerful, the demand for ethical oversight will increase proportionally. Because here is the fundamental truth: we need humans watching the machines. Part 2 explores the specific technical roles that will survive and thrive in an artificial intelligence-dominated world. What we cover next could save your career. Every artificial intelligence model is only as good as the data it was trained on. Garbage in, garbage out. This ancient computing principle becomes exponentially more important in the age of machine learning. And who ensures the integrity of that data? Who maintains the systems that store, organize, and protect the information that artificial intelligence depends upon? database administrators. These professionals do not just manage storage systems, they are the guardians of truth in an increasingly artificial world. They ensure data accuracy. And here is something critical that most people miss. Artificial intelligence cannot effectively manage its own training data without creating dangerous feedback loops. If an artificial intelligence system is allowed to curate its own data sources, it will naturally gravitate toward data that reinforces its existing patterns. This creates echo chambers at a computational scale. Biases become amplified rather than corrected. Errors become institutionalized. Human database administrators serve as a circuit breaker in this process. They make judgment calls about data quality. They recognize when data sources have become corrupted or biased. They implement controls that prevent artificial intelligence systems from contaminating their own training environments. According to the United States Bureau of Labor Statistics, database administrator positions are projected to grow by 8% through 2032. But more importantly, the complexity and criticality of these roles is increasing dramatically. These are not jobs being replaced, they are jobs being elevated. The internet is not magic, it is infrastructure. Work billions of packets traveling through billions of nodes, every single second of every single day, and someone has to design these systems. Someone has to determine how data flows from point A to point B. Someone has to balance competing priorities, speed versus security, capacity versus cost, redundancy versus efficiency. Network architects design the invisible highways that make digital civilization possible. And despite advances in artificial intelligence, this remains fundamentally a human discipline. Why? Because network design involves trade-offs that have no objectively correct answer. What level of redundancy is appropriate for a financial institution versus a small business? How do you balance the needs of real-time video conferencing against bulk data transfer? What is the acceptable risk level for a healthcare network serving millions of patients? These are judgment calls, human judgment calls. The deployment of artificial intelligence itself is driving explosive growth in network infrastructure requirements. Models like GPT-4 require massive data center interconnections. Edge computing demands entirely new network topologies. The infrastructure needed to support artificial intelligence creates more demand for human architects, not less. There was a time when every company maintained its own servers. That time is ending. The migration to cloud computing represents one of the most significant shifts in information technology history. And while cloud platforms provide unprecedented automation, someone still needs to design, implement, and manage cloud deployments. Cloud infrastructure specialists are the new landlords of the digital economy. They determine how organizations use Amazon Web Services, Microsoft Azure, Google Cloud Platform, and dozens of other providers. They architect multi-cloud strategies. They optimize costs that can easily reach millions of dollars annually for large enterprises. And here is the critical insight. Cloud automation does not eliminate the need for human specialists. It elevates them. When infrastructure becomes code, mistakes become expensive at scale. A misconfigured security group does not affect one server. It affects thousands. A poorly designed auto-scaling policy does not waste a few dollars. It can generate bills in the hundreds of thousands overnight. According to Gartner, worldwide end-user spending on public cloud services is projected to exceed $675 billion in 2024. $675 billion. And every single dollar of that spending requires human professionals to plan, implement, and optimize. The cloud is not replacing information technology jobs, it is transforming them. And those who master cloud infrastructure will find themselves among the most valuable professionals in the industry: development and operations. Two tribes that historically viewed each other with suspicion. Developers wanted to ship code fast. Operations wanted to maintain stability. These goals often conflicted. Releases were painful. Deployments were risky. Coordination was minimal. They build the pipelines that transform code into running services. They create the automation that makes continuous deployment possible. Engineers do not just build automation, they design automation strategies. They make decisions about what should be automated and what should not. They troubleshoot when automation fails. They evolve systems as organizational needs change. Artificial intelligence can execute pipelines. Artificial intelligence can run tests. But artificial intelligence struggles with the judgment calls that define good practice. When should you roll back a deployment? When is a test failure acceptable? When should you bypass normal procedures for an emergency fix? These decisions require understanding of business context, team dynamics, and acceptable risk levels that artificial intelligence cannot reliably assess. Its role is evolving, certainly. Platform engineering is emerging as a specialization, but the fundamental need for humans who can bridge technical and organizational boundaries remains strong. Google invented this role. Then, the world adopted it. Site reliability engineers are responsible for maintaining the availability and performance of systems at scale. They are the professionals who ensure that when you click a button, something actually happens, that when you search for information, results appear, that when you send a message, it reaches its destination. This seems like exactly the kind of work that artificial intelligence should excel at. Pattern recognition, anomaly detection, automated remediation, and indeed, artificial intelligence tools are transforming how site reliability work is performed. But here is what the headlines miss. Artificial intelligence is augmenting site reliability engineers, not replacing them. Why? Because reliability at scale involves constant trade-offs. How much redundancy is enough? When should you take the risk of a major upgrade versus accumulating technical debt? How do you balance feature velocity against system stability? These are not optimization problems with clear objective functions. They are judgment calls that require understanding of organizational priorities, customer expectations, and business constraints. According to Robert Half Technology salary data, site reliability engineers command some of the highest salaries in the information technology industry. Median compensation exceeds $170,000 annually, and demand continues to outstrip supply. The artificial intelligence revolution makes these professionals more valuable, not less. Because the systems being built are more complex, the stakes are higher. The need for human judgment at critical moments becomes more acute. We spend so much time talking about software that we forget a fundamental truth. Everything runs on hardware. Every artificial intelligence model, every cloud service, every application you use daily, ultimately executes on physical silicon chips in physical data centers consuming physical electricity. Hardware specialists work at this crucial intersection. They diagnose failing components. They optimize thermal management. They plan hardware refresh cycles. They ensure that the physical foundation of our digital world remains solid. And here is why this role remains stubbornly resistant to automation. Hardware problems are physical problems. A server with intermittent failures does not produce clean log data. A networking issue caused by a slightly unseated cable does not trigger software alerts. A drive approaching failure might pass all automated diagnostics until it fails completely. Diagnosing these issues requires physical presence. It requires the ability to hear unusual sounds, feel abnormal vibrations, see visual indicators that cameras might miss. It requires the intuition that comes from years of hands-on experience. The artificial intelligence boom is creating unprecedented demand for hardware infrastructure. New data centers are being built at a furious pace. Existing facilities are being expanded. All of this requires human specialists who understand the physical systems that make digital magic possible. The internet does not just exist. It travels through fiber optic cables buried under oceans, through microwave towers spanning deserts, through satellites orbiting thousands of miles above the Earth, through cell towers that dot every urban landscape. Telecommunications specialists maintain this global nervous system. They ensure that data can flow from anywhere to anywhere. They troubleshoot issues that span multiple providers, multiple technologies, multiple jurisdictions. And this role is expanding, not contracting, for one simple reason: artificial intelligence requires massive bandwidth. Training a large language model can require transferring petabytes of data. The infrastructure requirements of artificial intelligence are driving the largest telecommunications build-out in human history. Fifth-generation wireless networks, satellite internet constellations, subsea cable upgrades. All of this requires human specialists to design, deploy, and maintain. According to the International Telecommunication Union, global internet traffic is growing at approximately 25% annually. 25%. This exponential growth demands exponential expansion of telecommunications infrastructure. And infrastructure requires people, physical people who can climb towers, splice fibers, configure routers, and troubleshoot problems that span the globe. Subscribe now. The next chapters reveal even more critical roles that will survive the artificial intelligence revolution. In the digital world, identity is everything. Who are you? What are you allowed to access? How do we prove that you are who you claim to be? These questions form the foundation of information security, and the professionals who manage these systems, identity and access management specialists, are becoming more critical than ever. Consider the implications of artificial intelligence for identity. Deepfakes can replicate voices and faces with alarming accuracy. Social engineering attacks become more sophisticated when powered by machine learning. Traditional authentication methods are being overwhelmed by artificial intelligence-powered attacks. This creates a paradox. The better artificial intelligence gets at impersonating humans, the more valuable human identity specialists become. These professionals design authentication systems that can withstand advanced attacks. They implement zero-trust architectures that assume every access request might be malicious. They develop behavioral analytics that can detect when someone is not who they claim to be. But more than technical skills, these roles require judgment. Who should have access to what? When should access be revoked? How do you balance security against usability? How do you handle the political dynamics when an executive demands access they should not have? These are human questions that require human answers. According to the Identity Management Institute, the global identity and access management market is projected to exceed $25 billion annually by 2028. $25 billion in a single cybersecurity subspecialty. Hope for the best, plan for the worst. Disaster recovery specialists are the professionals who plan for the worst. They design systems that can survive data center fires, ransomware attacks, natural disasters, and cascading failures. They create the contingency plans that keep organizations operational when everything else goes wrong. And artificial intelligence makes their role more important than ever. Why? Because artificial intelligence introduces new categories of disaster. What happens when a machine learning model becomes corrupted? What happens when an artificial intelligence system makes a catastrophically wrong decision? What happens when automated systems cascade failures faster than any human can respond? Traditional disaster recovery focused on hardware failures and natural disasters. And modern disaster recovery must also account for artificial intelligence failures, and these failures can be subtle, difficult to detect, and devastating in their consequences. Disaster recovery also requires something artificial intelligence cannot provide: organizational trust. When a true disaster strikes, someone needs to make the call, activate the backup site, declare the emergency, authorize the extraordinary measures. These decisions have massive financial and legal implications. They cannot be delegated to machines. Organizations need human specialists who understand both the technical systems and the business implications, who can coordinate across departments during chaos, who can make judgment calls when the playbook does not cover the situation. Here is a job function that rarely makes lists of exciting technology careers. Vendor management specialists handle relationships with technology providers. They negotiate contracts. They resolve disputes. They ensure that service-level agreements are met. They coordinate across multiple vendors to deliver integrated solutions, and artificial intelligence cannot replace them for one fundamental reason: business relationships require human trust. When a critical system fails at 2 in the morning, you do not want to negotiate with a chatbot. You want a human being at your vendor who knows your name, understands your situation, and is willing to go beyond the contract to help. When negotiating a multi-million-dollar technology agreement, you need humans on both sides. Legal implications, political dynamics, unstated assumptions, face-to-face relationship building. These elements of business simply do not translate to artificial intelligence. According to Gartner, the average enterprise uses more than 100 different technology vendors, 100 different relationships that need human management, each with its own contracts, service levels, escalation procedures, and political dynamics. As technology ecosystems become more complex, vendor management becomes more challenging, and the professionals who can navigate this complexity become more valuable. If you have made it this far, you are serious about your career. Hit that subscribe button because we are about to explore specialized roles that most people do not even know exist. Power plants, water treatment facilities, manufacturing lines, transportation networks. These systems run on industrial control technology that predates modern information technology practices. Programmable logic controllers designed in the 1980s. Supervisory control and data acquisition systems that were never intended to connect to the internet, and yet connect they have. The efficiency gains were too attractive to ignore. Remote monitoring, predictive maintenance, centralized management. the industrial world went digital. The security implications are terrifying. Industrial control system security specialists protect the infrastructure that keeps civilization running. They understand both the information technology world and the operational technology world. They can speak the language of plant managers and network administrators. This specialization is desperately understaffed. According to SANS Institute research, more than 60% of industrial facilities have experienced a cybersecurity incident in the past year. 60%. And the talent pool of professionals who understand both domains remains dangerously small. Artificial intelligence cannot replace these specialists because the systems themselves resist modernization. You cannot simply upgrade a power plant's control systems the way you upgrade a phone app. These systems require human experts who understand legacy technology, physical safety constraints, and regulatory requirements. The salaries in this field reflect the scarcity. A senior industrial control system security professionals routinely command compensation exceeding $200,000 annually. Medical errors kill more than 250,000 Americans every year. That is the third leading cause of death, behind only heart disease and cancer. And increasingly, healthcare depends on information technology systems that must work perfectly, every single time. Healthcare specialists understand both the technology and the clinical environment. They implement systems that support life-critical decisions. They ensure compliance with healthcare-specific regulations like HIPAA. They manage the complex integration between medical devices, electronic health records, and clinical workflows. And artificial intelligence makes these specialists more important, not less. Artificial intelligence is transforming healthcare. Diagnostic support, treatment recommendations, automated monitoring. These applications promise to save lives, but they also introduce risks that require human oversight. What happens when an artificial intelligence system recommends the wrong treatment? What happens when automated monitoring fails to alert clinicians to a deteriorating patient? What happens when the electronic health record contains errors that propagate through artificial intelligence decision support? Healthcare, its specialists serve as the human safeguard against these failures. They validate artificial intelligence systems before deployment. They maintain the manual overrides that clinicians need when automated systems fail. According to the Healthcare Information and Management Systems Society, healthcare at job postings have increased by over 20% year over year. The industry simply cannot train specialists fast enough to meet demand. The global financial system processes more than $5 trillion in foreign exchange transactions alone, moving through interconnected systems at speeds that humans cannot perceive. Automated trading algorithms making thousands of decisions per second. Payment networks linking billions of accounts across millions of institutions. Financial technology security specialists protect this massive flow of wealth. They understand both the technical systems and the regulatory environment. They implement controls that prevent fraud, detect money laundering, and maintain market integrity. And the artificial intelligence revolution is creating new categories of financial crime that these specialists must counter. Deepfakes enable sophisticated fraud. Machine learning powers unprecedented market manipulation. Artificial intelligence can generate synthetic identities that pass traditional verification. The attackers have powerful new tools, but defenders cannot simply deploy their own artificial intelligence and call it done. Financial regulations require human accountability. When something goes wrong, regulators demand human explanations, human testimony, human responsibility. Automated systems can support this work, but they cannot replace the human element. According to Deloitte research, financial services firms spend more than 10% of their technology budgets on cybersecurity. For the largest institutions, that represents billions of dollars annually. Much of that spending flows to the human specialists who provide judgment, accountability, and expertise that machines cannot replicate. Every piece of technology exists within a legal framework. Accessibility requirements, environmental regulations. The legal landscape surrounding technology becomes more complex every year. Legal technology specialists bridge the gap between technologists and lawyers. They understand both the systems being built and the regulations governing them. They translate legal requirements into technical specifications. They ensure that products comply with laws across multiple jurisdictions. And artificial intelligence is creating entirely new categories of legal complexity. Who is liable when an artificial intelligence system causes harm? How do intellectual property rights apply to content generated by machines? What privacy rights apply to data used to train models? How do anti-discrimination laws apply to algorithmic decisions? These questions do not have clear answers. They require human judgment, precedent analysis, and risk assessment that artificial intelligence cannot reliably provide. The European Union's Artificial Intelligence Act alone runs to more than 400 pages of regulatory requirements. 400 pages. And it is just one jurisdiction among many that organizations must navigate. Legal technology specialists who can interpret and implement these requirements will remain in high demand for decades. More than 1 billion people worldwide live with some form of disability. 1 billion people who need technology to work differently than it does for the majority. Screen readers for the blind, voice control for those who cannot use traditional input devices, captions for the deaf, cognitive accommodations for those with learning differences. Accessibility specialists ensure that technology works for everyone. They understand the diverse ways that humans interact with digital systems. They implement standards that expand rather than restrict who can participate in the digital world. Artificial intelligence presents both opportunities and challenges for accessibility. Artificial intelligence can generate alt text for images. Artificial intelligence can power real-time captioning. Artificial intelligence can enable new forms of adaptive interfaces. But artificial intelligence can also create new barriers. Voice interfaces that do not understand speech differences, image recognition that fails for certain user groups, automated systems that inadvertently discriminate. Accessibility specialists provide the human judgment needed to identify and correct these problems. They advocate for users who are too often overlooked in technology design. They ensure that efficiency gains do not come at the cost of exclusion. According to the World Health Organization, the market for assistive technology alone exceeds $20 billion annually. Organizations increasingly recognize that accessibility is not just ethical, it is economically essential. Like this content and subscribe. The specialized roles we cover next are even more critical to the future of technology. Code shifts, bugs follow. This fundamental reality of software development has not changed since the first programs were written. And while artificial intelligence can generate code at unprecedented speeds, it can also generate bugs at unprecedented speeds. Quality assurance engineers serve as the last line of defense before software reaches users. They design test strategies. They identify edge cases that developers missed. They validate that systems work as intended across diverse environments. And here is the critical insight: artificial intelligence cannot fully replace quality assurance because quality is ultimately a human judgment. What constitutes acceptable performance? What level of risk is appropriate for a given application? What user experiences are good enough to ship? These questions do not have objective answers. They require human judgment. Artificial intelligence can certainly augment quality assurance work, automated test generation, intelligent test selection, predictive defect analysis. These tools are transforming the field, but the strategic decisions remain human. The judgment calls remain human. The accountability for quality remains human. According to the World Quality Report, organizations spend an average of 23% of their technology budgets on quality assurance and testing. 23%. A quarter of technology spending flows to the professionals who ensure that systems actually work. Every new technology creates a training gap. Engineers need to learn new tools. Users need to understand new interfaces. Organizations need to adopt new practices, and artificial intelligence is creating the largest training gap in the history of technology. Technical trainers and educators bridge this gap. They translate complex concepts into understandable lessons. They design curricula that actually work. They adapt their approaches to different learning styles and organizational contexts. And here is why this role resists automation. Effective teaching requires human connection. Learning is not just information transfer. It is motivation. It is encouragement. It is understanding when a student is struggling and adjusting the approach. It is recognizing when frustration is blocking progress and providing emotional support. Artificial intelligence can deliver content. Artificial intelligence can answer questions. But artificial intelligence cannot provide the human mentorship that transforms struggling learners into confident practitioners. According to LinkedIn Learning data, demand for technology training has increased by more than 50% since 2020. The rapid pace of change means that learning never stops. Professionals must continuously update their skills, and professionals learn best from other professionals, from human teachers who have walked the path themselves, who can share not just knowledge, but wisdom. Technology projects fail at an alarming rate. According to the Project Management Institute, approximately 14% of projects are deemed failures, but that understates the problem. Another 31% do not meet their original goals. Only 55% of projects are considered successful. Technical project managers work to improve these odds. They coordinate across teams, they manage risks, they navigate the political dynamics that determine whether projects succeed or fail. And artificial intelligence cannot replace this role because project management is fundamentally about human coordination. Projects do not fail because of technical problems alone. They fail because of communication breakdowns, misaligned expectations, political conflicts, resource constraints. Organizational dysfunction. Resolving these problems requires emotional intelligence, the ability to read a room, to understand unstated concerns, to build coalitions, to motivate teams through challenges, to deliver difficult news in ways that preserve relationships. These are human skills that artificial intelligence cannot replicate. The demand for project managers continues to grow. According to the Project Management Institute, the global economy will need 25 million new project professionals by 2030. The gap between supply and demand represents one of the largest talent shortages in the professional world. What happens when everything goes wrong simultaneously? A pandemic shuts down offices worldwide. A cyber attack cripples critical systems. A natural disaster destroys a primary facility. A key vendor suddenly fails. Business continuity planners prepare organizations for these scenarios. They identify critical dependencies. They develop response procedures. They conduct exercises that test organizational resilience. They ensure that when disaster strikes, the organization can survive. And artificial intelligence creates new categories of business continuity risk. What happens when an artificial intelligence system that the organization depends upon suddenly becomes unavailable? What happens when a model update changes behavior in unexpected ways? What happens when an artificial intelligence vendor is acquired, changes pricing, or discontinues service? Business continuity planners must incorporate these artificial intelligence-specific risks into their frameworks. They must ensure that organizations are not creating dangerous dependencies on systems they do not fully control. According to the Business Continuity Institute, more than 70% of organizations experienced at least one business disruption in the past year. The need for professionals who can help organizations survive and recover remains constant. Individual systems are easy. Coordinating hundreds of systems is hard. Enterprise architects are responsible for the big picture. They design frameworks that allow diverse technologies to work together. They establish standards that enable integration. They create roadmaps that guide technology evolution over years and decades. And artificial intelligence cannot replace this role because enterprise architecture is fundamentally about organizational strategy. Technology decisions are not made in isolation. They reflect business priorities. They embody organizational values. They determine competitive capabilities. They shape what an organization can become. Understanding these connections requires deep organizational knowledge. It requires relationships with executives across the business. It requires the ability to translate between technical possibilities and business requirements. Artificial intelligence can optimize individual components, but the judgment about which components matter, how they should connect, and how the overall architecture should evolve remains fundamentally human. According to Gartner, enterprise architecture practices can reduce total cost of ownership by up to 30% while accelerating time to market. But achieving these results requires human architects who can navigate organizational complexity. Part 4 explores the emerging roles at the interface between human and artificial intelligence. These are the careers that literally did not exist 5 years ago. Deploying an artificial intelligence model is just the beginning. Models drift, data changes, performance degrades, edge cases emerge. What worked in testing fails in production. What worked yesterday fails today. Specialists manage artificial intelligence systems throughout their life cycle. They monitor model performance. They detect drift. They manage retraining pipelines. They ensure that deployed systems continue to work as intended. This role is one of the fastest growing specializations in all of information technology. According to MLOps community surveys, more than 80% of machine learning projects fail to reach production. The gap between data science experiments and operational systems remains enormous. Bridging this gap requires specialists who understand both the data science and the operational infrastructure, who can speak the language of both worlds, who can navigate the organizational challenges of deploying systems that nobody fully understands, And critically, these specialists provide human oversight of artificial intelligence systems. Someone needs to decide when a model is performing well enough. Someone needs to recognize when unexpected behavior indicates a problem. Someone needs to make the call to roll back a deployment that is causing harm. These decisions cannot be delegated to other artificial intelligence systems. The recursive problem of artificial intelligence, monitoring artificial intelligence, accountability gaps that only humans can fill. A new skill emerged from the artificial intelligence revolution, the ability to communicate effectively with machines. Prompt engineers design the inputs that shape artificial intelligence outputs. They understand how different phrasings elicit different behaviors. They craft system prompts that establish consistent personalities. They debug interactions when outputs go wrong. Wait, did we not say earlier that artificial intelligence can design prompts better than humans? Yes, and that is precisely why human prompt engineers remain valuable. Artificial intelligence can optimize prompts for specific metrics, but humans determine which metrics matter. Humans evaluate whether outputs actually meet human needs. Humans recognize when technically optimal prompts produce ethically problematic results. Prompt engineering at the basic level is becoming commoditized. Simple prompts for common tasks do not require specialists, but strategic prompt design for enterprise applications remains highly human. How should a customer service chatbot handle angry customers? What tone should an internal assistant use? When should an artificial intelligence system refuse requests? These decisions require human judgment about organizational values and user needs. According to job market data, prompt engineering positions have grown from near zero in 2020 to thousands of open roles in 2024. The field is rapidly professionalizing with certifications, best practices, and specialized tools. Artificial intelligence learns from data, and data does not curate itself. Training data specialists select, prepare, label, and validate the data that artificial intelligence systems learn from. They identify biases. They ensure quality. They make judgment calls about what information should and should not be included in training sets. This role is far more important than most people realize. Every bias in artificial intelligence output can be traced back to training data. Every unexpected behavior reflects patterns learned from data. Every limitation exists because the training data did not cover certain scenarios. Training data specialists provide human judgment at this critical juncture. They decide what examples to include. They determine how to handle edge cases. They identify when data sources introduce problematic biases, and they cannot be replaced by artificial intelligence for a fundamental reason. Using artificial intelligence to curate artificial intelligence training data creates feedback loops that amplify existing problems. According to Scale I research, the quality of training data has a larger impact on model performance than model architecture for many applications. Data quality trumps algorithmic sophistication. Organizations are increasingly recognizing that competitive advantage comes from data advantage. And data advantage requires human specialists who can evaluate, curate, and improve training data. How do you find vulnerabilities in systems you do not fully understand? Red team specialists attack artificial intelligence systems. They probe for weaknesses. They discover jailbreaks. They identify ways that systems can be manipulated to produce harmful outputs. This adversarial mindset is essential for artificial intelligence safety. Artificial intelligence systems are not secure by default. They can be manipulated in subtle ways that their creators never anticipated. Injections can override safety guidelines. Carefully crafted inputs can produce dangerous outputs. Social engineering can trick systems designed to be helpful. Red team specialists think like attackers. They approach systems with creativity and malicious intent, imagining all the ways that bad actors might abuse these powerful tools. And this work requires human creativity. Artificial intelligence can scan for known vulnerability patterns, but truly novel attacks emerge from human imagination. From the ability to think outside established categories, from the willingness to try approaches that seem ridiculous until they work. According to OpenAI and other artificial intelligence labs, red team testing has identified critical vulnerabilities that automated testing missed. A human creativity remains essential for finding the unexpected ways that systems fail. Power without governance becomes tyranny. Governance specialists establish frameworks for responsible artificial intelligence use within organizations. They develop policies, they implement controls. They ensure accountability. They create the rules that guide how artificial intelligence is deployed and managed. This role is exploding in importance as artificial intelligence becomes central to business operations. Organizations are facing increasingly complex questions. Decisions can be delegated to artificial intelligence. What level of human oversight is required? How should errors be handled? What are the ethical boundaries for artificial intelligence use? Governance specialists develop answers to these questions. They translate organizational values into operational policies. They balance innovation against risk. They create accountability structures that work across complex organizations. And artificial intelligence cannot govern itself. The fundamental premise of governance is external oversight. A system cannot be its own regulator. The conflicts of interest are insurmountable. Effective governance requires independent human judgment. According to the World Economic Forum, more than 80% of organizations now view artificial intelligence governance as a board-level concern. Executive attention is driving investment in governance capabilities. Like and subscribe. The roles we cover next are among the most critical for surviving the artificial intelligence revolution. When humans and artificial intelligence work together, someone must design that collaboration. A human-eye interaction designers create the experiences through which people engage with artificial intelligence systems. They determine how systems present information, how they request input, how they handle uncertainty, how they fail gracefully. This specialization draws from user experience design, cognitive psychology, and artificial intelligence understanding. It requires empathy for human users and deep knowledge of artificial intelligence capabilities and limitations, and the design decisions matter enormously. How an artificial intelligence system communicates affects whether users trust its outputs. How it handles errors affects whether users can recover from mistakes. How it explains its reasoning affects whether users can effectively oversee its decisions. Poor design creates systems that users either overtrust or undertrust, systems that confuse rather than clarify, systems that disempower rather than augment human capability. Good design creates collaborative relationships between humans and machines, systems that enhance human judgment rather than replacing it, systems that keep humans in control while leveraging artificial intelligence capabilities. According to Nielsen-Norman Group research, organizations that invest in human interaction design see significantly better outcomes from their artificial intelligence deployments. The human interface matters as much as the underlying technology. Artificial intelligence systems are often described as black boxes. Data goes in, decisions come out. Nobody fully understands what happens in between. Explainability specialists work to open these black boxes. They develop techniques for understanding how models reach conclusions. They create visualizations that help humans comprehend machine reasoning. They translate algorithmic decision-making into human, understandable explanations. This work is becoming legally required in many contexts. The European Union's General Data Protection Regulation includes a right to explanation for automated decisions. The United States Equal Credit Opportunity Act requires explanations for credit denials. Healthcare regulations demand explainability for diagnostic systems. Beyond legal requirements, explainability enables effective human oversight. You cannot effectively oversee a system you do not understand. You cannot correct errors. You cannot identify. You cannot improve processes. You cannot analyze. Explainability specialists bridge the gap between mathematical optimization and human comprehension. They make artificial intelligence systems accountable by making them understandable. According to Gartner, explainability will be a requirement for 75% of all artificial intelligence projects by 2026. Organizations are recognizing that black box systems create unacceptable risks. Artificial intelligence systems can discriminate. And often, they discriminate in ways their creators never intended. Bias auditors examine artificial intelligence systems for unfair outcomes. They test whether systems treat different groups differently. They identify sources of bias in training data and model design. They recommend remediation strategies. This work requires both technical skills and understanding of social justice. Bias can be subtle. A hiring algorithm might not explicitly discriminate, but might learn to penalize characteristics correlated with protected categories. A lending algorithm might achieve overall accuracy, while systematically disadvantaging specific communities. Detecting these patterns requires statistical sophistication and human judgment about what constitutes fairness. Different definitions of fairness can conflict with each other. Auditors must navigate these tensions, and bias auditing cannot be fully automated because fairness itself is a human value judgment. Different stakeholders have different perspectives on what fair means. Affected communities must have voice in determining whether systems serve their interests. These conversations require human participation. According to Brookings Institution research, algorithmic bias has been documented across criminal justice, healthcare, hiring, lending, and numerous other domains. The need for auditors who can identify and address these problems will only grow. Technology does not exist in a vacuum. It exists within policy frameworks that shape its development and deployment. Policy analysts study the intersection of artificial intelligence and public policy. They analyze proposed regulations. They assess the implications of different policy choices. They advise governments, organizations, and civil society on artificial intelligence governance. This work is becoming increasingly critical as artificial intelligence transforms society. Governments worldwide are grappling with artificial intelligence regulation. The European Union has passed comprehensive artificial intelligence legislation. The United States is developing sector-specific approaches. China has implemented its own regulatory framework. Policy analysts help stakeholders understand these evolving frameworks. They anticipate how regulations might develop. They assess compliance requirements. They advocate for policies that balance innovation with protection. And this work requires human judgment about values and priorities. Policy analysis is not just technical. It involves trade-offs between competing goods, innovation versus safety, efficiency versus employment, power versus accountability. These trade-offs cannot be resolved algorithmically. According to the Stanford Institute for Human-Centered IA, the number of artificial intelligence-related laws passed by legislatures worldwide increased by more than 50% between 2022 and 2023. The policy landscape is evolving rapidly. Artificial intelligence is transforming every industry, but most people do not understand how. Communication specialists translate complex artificial intelligence concepts for non-technical audiences. They explain what systems can and cannot do. They set appropriate expectations. They combat hype and misinformation. They help people understand how artificial intelligence affects their lives. This work requires rare combination of technical understanding and communication skill. Most artificial intelligence experts cannot explain their work to general audiences. Most communicators do not understand the technology deeply enough to explain it accurately. Specialists who can bridge this gap are extremely valuable. And accurate communication about artificial intelligence is becoming a matter of public importance. Information about artificial intelligence affects policy debates. Unrealistic expectations lead to poor decisions. Fear and hype both distort public understanding in harmful ways. Communication specialists provide balance. They celebrate genuine capabilities without overpromising. They acknowledge real risks without fearmongering. They help people make informed decisions about how to engage with artificial intelligence. According to the Reuters Institute, public understanding of artificial intelligence remains low despite extensive media coverage. The gap between what artificial intelligence can actually do and what people believe it can do creates opportunities for specialists who can bridge that divide. Hit that subscribe button. Part 5 explores strategic roles that position you for leadership in an artificial intelligence-dominated world. At the top of the cybersecurity hierarchy sits the Chief Information Security Officer. CISOs lead organizational security strategy. They report to boards of directors, and the artificial intelligence revolution is transforming this role in profound ways. CISOs must now defend against artificial intelligence, powered attacks while leveraging artificial intelligence for defense. They must govern the security of artificial intelligence systems while using artificial intelligence to enhance security operations. The complexity is unprecedented. This is not a role that artificial intelligence can replace. Security leadership requires organizational trust. It requires the ability to communicate risk to non-technical executives. It requires judgment about acceptable risk levels. It requires the credibility to make unpopular decisions that protect the organization. According to the CISO research community, the average tenure of a Chief Information Security Officer is approximately 4 years. The role is demanding, stressful, and critically important. Those who succeed command compensation exceeding $500,000 annually at major organizations. The path to this role typically runs through the technical security specializations we discussed earlier. Senior security professionals who develop leadership capabilities can aspire to these strategic positions. Data is the new oil, and someone must manage this precious resource. Chief data officers lead organizational data strategy. They ensure data quality. They govern data access. They transform raw data into strategic advantage. And in the age of artificial intelligence, this role becomes central to competitive success. Artificial intelligence is only as good as its data. Organizations with better data will build better artificial intelligence systems. Organizations that can effectively leverage their data assets will outcompete those that cannot. They break down data silos, they establish data governance frameworks, they champion data literacy throughout the organization. This role requires both technical depth and business acumen. Pseudos must understand data architecture and analytics technology, but they must also understand business strategy, organizational dynamics, and change management. They must translate data capabilities into business value. According to New Vantage Partner surveys, the percentage of Fortune 1000 companies with chief data officers has grown from just 12% in 2012 to more than 80% today. The role has transitioned from novelty to necessity. A new executive role has emerged. Officers lead organizational artificial intelligence strategy. They identify opportunities for artificial intelligence application. They manage artificial intelligence talent and capabilities. They ensure responsible artificial intelligence deployment. This role sits at the intersection of technology, business, and ethics. CIOs must understand artificial intelligence technology deeply enough to assess opportunities and risks. They must understand business strategy deeply enough to identify high-value applications. They must understand ethical frameworks deeply enough to ensure responsible deployment. Organizations are creating these positions because artificial intelligence is too important and too risky to manage without dedicated executive leadership. Who makes the call when an artificial intelligence application fails? Who decides which artificial intelligence projects get funded? Who ensures that artificial intelligence deployment aligns with organizational values? According to LinkedIn data, positions have grown by more than 300% since 2022. Organizations are recognizing that artificial intelligence leadership requires executive attention. Every technology investment carries risk. Someone must quantify and manage that risk. Technology risk officers assess and manage technology. They evaluate cybersecurity exposures. They assess vendor dependencies. They quantify the financial impact of technology failures. And artificial intelligence introduces entirely new categories of risk: model risk, bias risk, explainability risk, dependency risk, competitive risk, regulatory risk. The risk landscape has become dramatically more complex. Technology risk officers provide frameworks for understanding and managing this complexity. They develop risk metrics. They establish risk tolerance levels. They ensure that organizations understand what they are getting into before they deploy artificial intelligence systems. This role requires quantitative sophistication and business judgment. Risk assessment involves probability estimation, impact analysis, and scenario planning. But it also involves judgment about which risks matter most, which can be mitigated, and which must simply be accepted. According to McKinsey research, organizations with mature technology risk management practices experience 40% fewer major incidents than those with immature practices. Effective risk management creates measurable value. Technology alone does not create value. Organizational change creates value. Digital transformation leaders guide organizations through technology-driven change. They align technology investments with business strategy. They manage the human side of technological change. They ensure that technology adoption actually delivers promised benefits. And the artificial intelligence revolution is the largest digital transformation in history. Artificial intelligence is not just another technology. It fundamentally changes how work gets done. It disrupts established processes. It threatens existing power structures. It requires entirely new organizational capabilities. Managing this transformation requires sophisticated change management skills. How do you help employees adapt to artificial intelligence augmentation? How do you overcome resistance from those who feel threatened? How do you maintain organizational culture through dramatic change? These are human challenges that require human leadership. According to research by the Boston Consulting Group, digital transformations fail at a rate of approximately 70%. The primary causes are not technical. They are organizational, leadership, culture, change management. The next chapters reveal how to position yourself for these strategic leadership roles. Not every organization can hire a full executive team for artificial intelligence. Strategic technology consultants provide external expertise to organizations navigating complex technology decisions. They provide objective perspective. They accelerate learning by transferring knowledge from leading organizations to followers. And the artificial intelligence consulting market is exploding. Every organization is asking the same questions. How should we use artificial intelligence? What are the risks? Where should we invest? What should we build versus buy? Consultants who can provide answers command premium rates. This role combines deep technical knowledge with business advisory skills. Consultants must understand artificial intelligence technology well enough to assess opportunities accurately, but they must also understand business strategy, organizational dynamics, and implementation challenges. They must translate technical possibilities into business recommendations. According to Statista, the global management consulting market exceeds $200 billion annually. Technology strategy is one of the fastest-growing segments within this market. For experienced professionals, consulting offers a path to leverage accumulated knowledge while maintaining career flexibility. The skills developed in operational roles translate directly into advisory value. Billions of dollars flow into artificial intelligence startups every year. Someone must evaluate which investments will succeed. Venture capital technical advisors assess the technology behind startup investments. They evaluate whether products actually work. They assess whether technical teams can execute. They identify risks that business-focused investors might miss. This role requires both deep technical knowledge and investment judgment. Not every breakthrough paper translates into a viable product. Not every impressive demo represents sustainable competitive advantage. Not every talented team can scale. Technical advisors help investors separate genuine innovation from hype. And the artificial intelligence investment landscape is particularly challenging to navigate. Artificial intelligence capabilities are evolving so rapidly that yesterday's breakthrough is tomorrow's commodity. What seems defensible today might be replicated easily tomorrow. Technical advisors help investors understand these dynamics. According to PitchBook data, venture capital investment in artificial intelligence companies exceeded $60 billion in 2023 alone. $60 billion seeking technical opportunities. For experienced technologists, advisory roles offer an attractive late career path. The knowledge accumulated over decades becomes directly valuable for evaluating the next generation of technology. Corporate boards are increasingly grappling with technology oversight. Board-level technology advisors help directors understand technology risks and opportunities. They translate technical complexity into governance terms. They ensure that boards can effectively oversee management's technology decisions. This role has become critical as technology becomes central to corporate strategy. When artificial intelligence failures can destroy billions in shareholder value, when cybersecurity breaches can bankrupt companies, when technology strategy determines competitive success, boards must understand technology. But most board directors lack technical backgrounds. They understand finance, law, strategy, and operations, but they struggle with technology complexity. Advisors bridge this gap, translating technical realities into governance frameworks that directors can apply. According to the National Association of Corporate Directors, technology oversight is now among the top concerns for corporate boards. Directors recognize their responsibility but often lack the knowledge to fulfill it effectively. For senior technology professionals, board advisory roles offer prestigious opportunities to shape organizational strategy at the highest levels. The foundations of artificial intelligence were built in universities. Academic research leaders advance the theoretical foundations of artificial intelligence and its applications. They train the next generation of artificial intelligence professionals. They provide independent perspective on artificial intelligence development. And academia remains essential despite the concentration of artificial intelligence talent in industry. University research explores questions that industry might ignore. Basic research without immediate commercial application. Ethical frameworks that might constrain profitable applications. Long-term risks that short-term business cycles cannot address. Academic positions offer unique freedom. Researchers can pursue questions driven by curiosity rather than commercial potential. They can publish findings that industry might suppress. They can speak publicly on matters that corporate employees cannot. According to the Computing Research Association, Academic computer science positions are highly competitive but offer stable, long-term career paths. Those who achieve tenure enjoy remarkable job security and intellectual freedom. Artificial intelligence revolution increases demand for academic expertise. Policymakers seek academic input. Industry recruits academic talent. Media coverage drives public interest in academic perspectives. Some of the most important work in artificial intelligence happens outside traditional institutions. Independent safety researchers study artificial intelligence risks without commercial conflicts of interest. They identify dangers that industry might ignore. They advocate for safety measures that corporate incentives discourage. Dr. Yampolsky himself exemplifies this role. Working in academia, he has spent 15 years studying artificial intelligence safety. He coined the very term eye safety. He has documented the impossibility results that others prefer to ignore. He speaks truths that make people uncomfortable. Independent researchers provide essential perspective. Industry researchers face pressure to publish positive results. Corporate communications emphasize opportunity over risk. But someone must document the dangers. Someone must ask the uncomfortable questions. Someone must hold the line. This path is not easy. Independent research often lacks commercial funding. Speaking unpopular truths invites criticism. The work can feel lonely and futile. But the importance cannot be overstated. If artificial intelligence truly threatens human existence, the researchers who sound the alarm may be among the most important people in history. Part 6 returns to practical operational roles that will remain essential throughout the artificial intelligence transition. At the foundation of every information technology organization sits the help desk. Help desk professionals are the first point of contact when technology fails. They guide frustrated users. They translate technical complexity into understandable terms. And while artificial intelligence is transforming help desk operations, human leadership remains essential. Chatbots can handle routine inquiries. Automated systems can resolve common issues. But complex problems still require human judgment. Frustrated users still need human empathy. Escalation paths still require human management. Help desk leadership positions coordinate these human-artificial intelligence collaborations. Leaders determine which issues automated systems should handle. They design escalation procedures. They ensure quality across human and automated interactions. They manage teams that combine human agents with artificial intelligence tools. According to HIDI research, the combination of artificial intelligence and human agents delivers better outcomes than either alone. Artificial intelligence handles volume. Humans handle complexity. Leaders ensure the combination works. Entry-level help desk positions may decline, but leadership roles that coordinate humanized service delivery will persist. Career paths that move quickly into coordination and leadership remain viable. Complex systems require constant watching. Infrastructure monitoring specialists operate the observation systems that detect problems before they become crises. They configure alerts, they analyze patterns, they distinguish signal from noise in floods of telemetry data. Artificial intelligence is transforming how monitoring works. Anomaly detection algorithms can identify unusual patterns that humans would miss. Predictive analytics can anticipate failures before they occur. Automated correlation can connect related events across complex systems, but human specialists remain essential for several reasons. First, configuring these systems requires human judgment. What counts as anomalous? What threshold triggers an alert? What patterns indicate genuine problems versus benign variation? These decisions require understanding of business context that artificial intelligence lacks. Second, novel situations require human analysis. Artificial intelligence can detect that something unusual is happening, but understanding what that unusual thing means often requires human investigation and interpretation. According to Gartner, organizations invest an average of 5% of their information technology budgets in monitoring and observability tools. This investment drives demand for specialists who can implement and operate these systems effectively. How much infrastructure will you need next year, next decade? Capacity planning specialists predict future infrastructure requirements. They analyze growth trends. They forecast demand. They ensure that organizations have sufficient resources without wasteful over-provisioning. And artificial intelligence makes this work both easier and harder. Easier because machine learning can analyze historical patterns and predict future demand with impressive accuracy. Automated scaling can adjust capacity in real time. Harder because artificial intelligence workloads are extremely difficult to predict. A new model might require 10 times more compute than expected. A viral application might grow from thousands to millions of users overnight. Traditional forecasting methods fail under these conditions. Human specialists navigate this uncertainty. They understand not just the technical systems, but the business plans that drive demand. They can incorporate strategic initiatives that historical data cannot reflect. They can apply judgment when forecasts conflict. According to Uptime Institute research, capacity planning failures cost organizations millions of dollars annually in both over-provisioning and service degradation. Effective planning directly impacts the bottom line. Every change to a production system carries risk. Change management specialists control how modifications are made to critical systems. They evaluate proposed changes. They schedule implementation windows. They ensure that changes are reversible. They coordinate across teams to prevent conflicts. This discipline becomes more important, not less, as systems become more complex. Artificial intelligence systems are particularly challenging to change manage. Model updates can have unexpected effects. Changes to training data can produce unexpected behaviors. Change management specialists ensure that modifications are controlled and reversible. They require testing before deployment. They demand rollback plans. They enforce approval processes. They create the organizational discipline that prevents small changes from causing major incidents. According to IDLE best practice frameworks, change management is one of the most critical disciplines for maintaining service stability. Organizations that neglect change management suffer more frequent and more severe incidents.